Welcome to Ask and Learn.
Okay, for this problem, we'll use the ratio test to figure out when we get convergence here. For the ratio test, we do limit as n goes to infinity of an plus 1 over an, where the an terms is this whole thing, so including the x values here. So that's limit as n goes to infinity of absolute value of x minus 2 to the n plus 1 divided by n plus 1 squared plus 1. So that's our an plus 1, and we're dividing that by an, so multiplying by the reciprocal. So we're multiplying by n squared plus 1 over x minus 2 to the n. Okay, so x minus 2 to the n plus 1 divided by x minus 2 to the n is just going to be x minus 2. And then we have n squared plus 1 divided by n plus 1 squared plus 1. So these up top and down below, we have degree 2 polynomials with leading coefficient 1. So as n goes to infinity, this is just going to go to 1. So this is just going to turn out to be absolute value of x minus 2. And we want for that to be less than 1. Okay, so absolute value of x minus 2 is going to be less than 1 when x minus 2 is trapped between minus 1 and 1. So if we have that minus 1 is less than x minus 2, we can add 2 to both sides and see that that corresponds to 1 is less than x. And if we have x minus 2 is less than 1, we can add 2 to both sides to see that that corresponds to x is less than 3. Okay, so the interval we're working with is from 1 to 3. And we're not sure whether or not we include 1 and whether or not we include 3 at this point. But the length of the interval is 3 minus 1, which is 2. So the radius of convergence is half of that. So the radius of convergence, r, is half of the interval of convergence, half of the length. The radius of convergence is just 1. And we need to figure out whether or not we include x equals 1 and whether or not we include x equals 3 for the interval of convergence. So when x is equal to 1, if we plug in 1 here, we have minus 1 to the n divided by n squared plus 1. And this is going to converge by the alternating sign test. So that's good. And the other thing we're wondering about is x equals 3. So if we plug in x equals 3 here, then we get 3 minus 2 to the n. So that's 1 to the n. 1 to the n is just 1. So we would get sum of just 1 over n squared plus 1. 1 over n squared plus 1 is going to converge because 1 over n squared converges. The exponent here is something that's bigger than 2, so we will get convergence here. And here the denominator is even bigger, right? If we make the denominator bigger, we're going to get something smaller. So since this converges, we have to have that this converges. So 3 works, 1 works. So we include both 3 and 1 in our interval of convergence.